Today we're going to be working on greatest common factor. I know we did this already before in the beginning, like October, during our different book. But since Savas introduced it now, I'm just going to grab it as a chance to review. So our goal will be to find the greatest common factor, or GCF, of two or more numbers using prime factorization, listing, or continuous division. So let's see if Savas worked today. All right, let's check. Oh, it works.
How can you use prime and composite numbers to write the prime factorization of a number? Think about this question during the lesson. Whole numbers greater than 1 are either prime or composite numbers. A composite number can be written as a product of its prime factors, called its prime factorization. How can you find the prime factorization of 48?
Let's take a look.
12 is a composite number because it has more than two factors. 5 is a prime number because the only factors of 5 are 1 and 5. Are all odd numbers prime numbers? Explain.
Can anybody answer the question? Are all odd numbers prime numbers? Anybody know that? Okay, go ahead.
No,
Why no? Can you add to your idea?
because for example, 9 is an odd number and it can be divisible by 3, 1, and 9 itself.
That's a very good point of view. Alex? Can odd number always be prime number?
I don't think so.
Can you give an example?
Wait, actually, screw what I just said. Actually, yeah, I think it makes sense because if a odd plus a odd is mostly even. I mean, always even.
But will it be prime number? Or not all the time?
Not all the time.
All right, so Travis, can you give me an example of a prime number?
A what number?
Prime number.
Alright, so prime number is like a number that like you can like multiply like many ways you could get by multiplying, and then which is the opposite of a what other name was that? The opposite of prime number.
It's a composite number.
Yeah.
So
basically the opposite of that.
The opposite of a composite number. Let's clarify a little bit. Okay, a prime number or a number that has factors that, what are the factors of a prime number again? Ada? Anybody who remember what are the factors of a prime number? Like for example, I have here 5. 5 is a prime number. And what are the factors of that, Alex?
Like an example of a prime number is like 12. You could do 1 times 12, 2 times 6, and then 3 times 4.
So is there anybody who'd like to go against or add something or like confirm to that one? All right, so quiet means you are all okay. But I just want to let you know that you switched the idea. Prime number are numbers that the factors is 1 and itself. All right, so it's only 1 and itself. You cannot have any other factor but 1 and itself. The example is 5. The factors of 5 are 1 and 5. The next one is 3. 3 times 1 is only 3. So the factors are only 3 times 1. 5, what else? Maybe 7. What are the factors of 7? 7 times 1, right? Before, who said that the number is 9? The number is an odd number, but it is not prime because we explained that 9 could be 3 times 3. But 9 could be also 9 times 1. So it means the factors of 9 are more than 1 in itself. So 9 is not a prime number even though it's odd. We call that number, what do we call this number? Anybody? If it is not prime, it is a? Alright, it's a composite number. Okay, we call it composite number. And the other one is a prime number. You don't switch them around, guys, okay? So just a little review. A prime number is 1 in itself, the factors of 1 in itself.
It's basically meaning prime numbers are numbers that only have 2 factors.
Yes, only 1 on itself. And the composite number is more than that. All right, it's the other way around that what you guys have explained. I hope you remember that. It's been a long time, so that's why it takes us a little while to really recall. All right, so let's move along. Let's clear this so we could proceed. All right.
No. For example, 9 is an odd number, but it has
example.
more than 2 factors, 3 times 3 and 9 times 1. So it is not prime. One way to find the prime factorization of 48 is to write its factors. It is sometimes helpful to start with the least prime factor. What number is always the least prime factor of any even number? Select your answer.
So what is the number that's always the least? Daniel said 2. Anybody else get a different answer? What is the least prime factor of any even number? Daniel said, why did you change your number, Daniel? Say factor of any even number. So let's take the first answer you got. That's what your first answer.
2 is the least prime factor of any even number.
I'll pause this for a second. Why do you think that you answer 1 is not the least? Because you said, oh, what was the least prime factor that you have? And the answer is 2 and not 1. Alex? Or anybody else? Is 1 considered prime number?
Yes.
Is prime
considered? It must have 2 positive numbers.
The prime is neither of both. All right, it could goes to both ways. So, but the lowest number, because anything that we're dividing by 1 will still be the same number. So what's the point of factoring it out, right? So the lowest number that we could use all the time is 2. Okay.
The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. Another way to show the prime factorization of a composite number is with a factor tree.
But before I go to the factor tree here, these are just looking at the 2 factors, all right? Then factor it again, and then factor it again until you cannot have any more factor to get, because these are all prime numbers. So 2, 2, 2, 2, and 3 are prime numbers already that you multiply together, it becomes 48. So the next example they're going to be shown to us is showing us the factor 3. And just a little recall again. Let's look.
You can use a factor tree to find the prime factorization of 48. Write 48 as the product of 2 factors. Continue the process until all of the factors are prime factors.
So with this said, so 48 could be 2 times 24. If I don't want to use 24 as one of my first factor, what do you think I could use? Because you will not just end up with 48 and just gonna have 24 and 2 as the first thing you need that you could think. You could only think of 24 if you were thinking of what is the first prime number I could use to factor out 48. So you said 2. But is there any other factor that you could think? What other factors? Let's say you were not able to think of a prime number right away. What other factors you have? Go ahead.
6 and 8.
We could do 6 and 8. So I could do 6 and 8. I did not think of a prime number right away, but that's okay because I still gonna end up with prime number. So I could circle all the prime numbers so I know that we are done with it, right? So that is the prime factorization of 48. And you could also answer this as 2. How many do you have? 1, 2, 3, 4 times 3. That's an exponential form of 2 times 2 times 2 times 2, 4 times. And then I'm going back here. Since 6 is not a prime number, I could find the factors of 6 to become a prime. What are those 2 factors that I could use to become 6?
3 and 2.
3 times 2. Is 3 a prime number? 3 a prime number? Yes or no? Guys, 3 is a prime number and 2 is a prime number. So I'm going to circle that.
3 and 2 are prime numbers.
All right, very good. So how about the factors of 8? What will it be?
4 and 2.
4 and 2. And 2 is already a prime number, so I'm going to circle that. I could not circle 4 yet because that is still
4 is not a
prime number. So I could continue. I would just continue working on 4. And what is 4?
2, 2.
2 times 2. And are they already prime?
Yes.
So we could go ahead and circle that as a prime number. So now there's no more that I need to factor out. So we're going to end up with 1, 2, 3, 4 factors of 2's and then 3. So we're still going to end up with the same number. So even though you started with a even numbers or not a prime number right away, like here with 2, it's okay. All right, even though you could also use 3 times a number equals 48. All right, so whatever you want to start with, it's fine. Question on a factor tree and prime factorization? So we could proceed to next, right? All right, let me clear this up.
The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. How can you check that the prime factorization is correct?
How could you check? How will we know that the prime factorization we have is really correct? What are we going to do? Anyone?
We can multiply all of the factors.
Very good, Tridi. Correct. So you could multiply all the factors, and if it answers 48, then we are correct. Let's see.
You can multiply all of the prime factors and confirm that the product is 48. Now you know how to use prime and composite numbers to write the prime factorization of a number.
Very nice. So let's see our second example. You know that you're going to do a question number 2, right? The next page, you're going to do it on your own. All right, this one. But let's see example number 2. So here you go. Let's listen to this.
Keisha is putting together bags of supplies. She puts an equal number of craft sticks and an equal number of glue bottles in each bag. There are no supplies left over. What is the greatest number of bags of supplies that Keisha can make?
So again, Keisha got 12 and 42 glue bottles. So he wants to put that in a baggie. So how many What is the greatest number that she could put them together? What will we do? So we're going to solve this using greatest common factor. So she got 12 bottles of glue and 42 craft sticks. So she wants to put them in a bag. So what possible number of bags she could put her supplies, there will be no leftover. So every bag has the same amount of supplies. So with that, we could use a greatest common factor. Daniel?
6.
So how do we get 6?
Because 12 divided by 6 equals 2, and 42 divided by 6 equals 8, and that's the greatest.
Oh, that is so nice idea. But I want you to look at this. Other strategy that we could use is we're gonna list all the factors of 12. Can you tell me all the factors of 12, please? Anybody? What are the factors of 12? Suzanne? Susanna?
6 times 2, 12 times 1, 3 times 4.
That's a good idea too. But can you list it down from lowest to the highest? Let's start with 1. And I heard you said 2. What do you think is the next number I could use that could be a factor of 12?
3.
Next.
4.
And then
6.
And then
12.
And then 12. Can someone give me the factors of 42? What are the factors of 42? Can we list down the factors of 42? So this strategy is by listing. Remember, we have those different strategies that we learned. In a previous example, we learned how to using prime factorization. So if we do not like to do that, there's another option of listing it out.
142.
All right, Jing, 1, and then what is the next number?
42.
That's already far. That's the last one. What's the next one?
Oh, sorry.
So we got 2, and then what else? Can 3 go, Jing? All right, Shin?
Yeah.
All right, Shin, could you continue? Can 3 goes to 42?
Yes.
Can 3 be a factor for... What's the next factor that I could use for 42?
6.
And then, continue. Can we use 7?
No.
8?
Yes.
9? 10?
No.
11? 12?
No.
Can we use 12? Can we use... What's next to 12? Then what's next to 8?
42.
Can we use 18?
Yes.
Okay. I think we could use 12. Look, we could use 12, right? Can we use 12?
No.
No. So we use 18. And the next to 18 is 42. Did we miss anything? All right.
No.
With that said, if you look at the list, what is the greatest common between the two? 12 and 42. Just by looking at the list, what do you have? So 1, 2, 3, 4, 6, 12, 1, 2, 3, 6, 8, 18, 42. The greatest common that we have, Alex? Was that you raising hand?
Oh no, I forgot.
Or Jing? Or Jing? Jing, was that you?
No.
All right, Shin?
6.
So we got 6. Look, the greatest common, even 1, 2, 3, or any number there is still okay for 12 and 42, but the greatest, the highest that is common between 12 and 42 is only 6. So we could say there are 6 bags it could make. Let's see what did Sava says and how it was done. All right. So let me clear that up and let's check. So here it also gives us the prime factorization of 12. It is 2 times 2 times 3. And then 42 will be 2 times 3 times 7. and then we collect all the common factors. So the common factors are 2 and 3. So with that, we have to the common factor between 12 and 42 is 2 and 3. So we multiply their common factors to get 6. Okay, so that is one of the strategy that we have. Did you guys know how to do continuous division? Did you learn how to do continuous division? So let's see. I have 12 over here, and then I have 42. I teach this in my previous class. In my class, I don't know if those who are in 604 remembers how to do this. So it's continuous division is like, but we're collecting all the common factors, right? What is the first number I could divide 12 and 42? First prime number, I mean. What is the first prime number that we could use to divide 12 and 42? What's the first number that you got in your mind? Shin said 2. All right, so I'll put 2 on this side. With that said, I could divide, I'll go back to green. 12 divided by 2 gives you 6. All right, so go back. I'll give me 6 over here. And then 42 divided by 2 gives you what? What's 42 divided by 2? 21, you said. And then I look again, 6 and 21. What is the greatest common factor? Prime factor, to be specific, between 6 and 21. Shin said 3. So now I could divide again. Between 6 divided by 3 gives us 2, right? And then 21 divided by 3 gives us what? Gives us 7. Yes, that's correct. Now if you look over 2 and 7, is there any other common factor between the two? There's no more, right? No more. Susan said no more. So the red one here, these are the common factors that we've taken from 12 and 42. So now we could multiply 2 times 3. This also gives us 6. So now we have 3 different ways of solving the greatest common factor. We have the prime factorization, we have the listing that we just did before, and we have a continuous division. So those are 3 different ways that we could use find the greatest common factor. We'll practice more and we're gonna learn. All right. So with that said, I want you to go to your Savas, to Google Classroom, and I want you to go here. Oh, I have that. I want to give the example. So I want you to go to your Google Classroom and check on the homework task that I give you and see what you could do. And then later on, we come back a little while before time's up. Or if not, then tomorrow we could work. Yes, that one, March 9, GZF and LCM. Let me double check. What is it? Let me go to Google Classroom. All right, but let's go to Google Classroom right now.